With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello, in this question given standard enthalpy and standard entropy change for the oxidation of ammonia at a 298 Kelvin era minus 582.64 kilojoule mole inverse and a minus 150.6 joule mole inverse Kelvin inverse respectively. Standard gives energy change for the same reaction at a 298 Kelvin. So in this question we have to given the oxidation of ammonia where its standard enthalpy change given and its standard entropy change is given at the temperature of a 298 Kelvin. We have to calculate the standard free energy change. So in this question we have to given the standard change in enthalpy. Standard change in enthalpy is represented by delta S, that is equal to, this is we have to given minus 582.64 kilojoule mole inverse, minus 582.64 kilojoule mole inverse and standard entropy change delta S, that is we have to given minus 150.6 minus 150.6 minus 150.6 joule mole inverse Kelvin inverse, joule mole inverse Kelvin inverse given, and we have to given temperature T, that is equals to 298 Kelvin. Temperature T, that is equals to 298 Kelvin. We have to calculate the change in Gibbs free energy. So we know that the relation between change in Gibbs free energy and change in enthalpy and change in entropy, that is equals to delta G, that is equals to delta H minus T delta S, delta H minus T delta S, where delta is the change in enthalpy, T is the temperature, delta is the change in entropy. So now we can calculate delta G, that is equal to delta H. Delta H value is the minus 582.64 minus 582.64 in kilojoule mole inverse, minus temperature T is the given 298 in Kelvin into delta S. The value of a delta is a given minus 150.6 minus 150.6 joule mole inverse Kelvin inverse, joule mole inverse and Kelvin inverse. So now Kelvin to Kelvin inverse get cancelled. So now the calculate from this part, we get a delta G, simplify this term, that is equals to minus 582.64 in kilojoule mole inverse, minus, that is the 298 into minus 150.6 joule mole inverse, So now minus into minus is the plus. So now the rearrange the term, we get a delta G, that is equals to minus 582.64 in kilojoule mole inverse plus 298 into 150.6 joule mole inverse. So now this is the here is the unit is kilojoule mole inverse, here is the unit is a joule per mole inverse. So when the unit is not same, then we not add. So first we have to same the unit, because when both the unit are the same, then we can add. So there is a joule. So we convert first in a kilojoule mole inverse. So when we convert in joule into kilojoule, we have to divide it by the 1000. So now the rearrange the term, simplify the term, that is equals to delta G, that is equals to minus 582.64 kilojoule mole inverse plus 298 into 150.6 whole divided by 1000 in kilojoule mole inverse. Now we can add easily because both the unit are the same. So now the calculate from this part, we get the standard change in Gibbs free energy delta G, that is equals to minus 537.76 in kilojoule mole inverse, So for the given reaction, the standard Gibbs free energy change, we can write the standard Gibbs free energy change, standard Gibbs free energy change, that is the delta G, that is equals to minus 537.76 kilojoule mole inverse. So the correct option is the, which option is the correct? Minus 537.76 537.76, that is option number 2, minus 537.7 kilojoule mole inverse. So I hope this answered your question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.